Starting with the inequality on the left, we note that this inequality is of the absolute value of some algebraic expression being less or equal than a constant type, and such inequalities are equivalent to the compound inequality, where you have that algebraic expression being less or equal than the constant or being greater or equal than negative constant. So in our case, the algebraic expression is this everything that we have inside of absolute value, and the constant is that 20. So we're looking on 3 times x minus 1 plus 2 being less or equal than 20, and being greater or equal than negative 20. So that's the main step in the absolute value of something part. Now that we have this inequality without absolute values, we start solving it in the usual way. So we distribute 3 over x minus 1. We have 3x minus 3 plus 2 in the middle. So combine negative 3 and 2, and we end up with 3x minus 1 in the middle. Now we're going to add 1 to all three sides of this compound inequality. So we're ending up with negative 19 being less or equal than 3x less or equal than 21. And if we divide all the way by 3, we're looking on negative 19 thirds being less or equal than x, less or equal than 21 thirds, and 21 over 3 is equal to 7. So that's the inequality that we end up with. A graphical representation of that same inequality is interval between negative 19 thirds and positive 7. And the interval notation for that is the interval between negative 19 thirds and 7. So that's the end with that inequality. Moving on to this inequality on the right-hand side, this inequality is of a different type. It has absolute value of some expression being greater than a number. And it is equivalent to two separate inequalities. So one is the inside of absolute value being greater than the constant. So that's one option. Another option is the inside of absolute value is the content of the absolute value is less than negative constant. So in our case, we're going to have those two options. 5 minus 2 sevenths x is greater than 5. Or 5 minus 2 sevenths x is less than negative 5. And so those two inequalities are to be solved separate, and since we have or between them, we're going to take the answer to the left and put it together with the answer for the right inequality. So to solve the first one, we subtract 5 from both sides, and we end up with negative 2 sevenths x being greater than 0. Now we're going to multiply both sides by negative 7 halves to cancel out negative 2 sevenths. When we do so, the inequality sign should be reversed because we're multiplying by a negative number, and we end up with x being less than 0. In a similar way, we deal with inequality on this right portion. So subtract 5, we end up with negative 2 sevenths x being less than negative 10. Then multiply by negative 7 halves, and as we do so, we have to flip the inequality sign because we multiply by the negative number. So on the left, we end up with x, and on the right, negative 10 times negative 7 halves is 35. So all in all, we have those two answers. For the leftmost inequality, we have x being less than 0. So it's everything to the left of 0. And for the right inequality, we have x being greater than 35, so it's everything to the right of 35. And for the answer, we get two of those intervals. So it's the interval from negative infinity to 0, union symbol, and the interval from 35 up to positive infinity. So we have those two intervals for the answer. So starting with the inequality on the left, we see that it's not yet solved for the absolute value, so that's what we start with. I'm going to solve for the absolute value of 3 minus x over 2. So we subtract 4 from both sides, and we're looking on absolute value of 3 minus x over 2 being greater or equal than 8. So this is the inequality of the type absolute value being greater or equal than a constant. It's going to be equivalent to two separate inequalities. So either the content of absolute value is less or equal than negative constant, or the content of the absolute value is greater or equal than the constant. So in our case, we end up with 3 minus x over 2 being less or equal than negative 8, or 3 minus x over 2 being greater or equal than 8. And so we're going to start solving each of those independently. So looking on the left portion, we're going to subtract 3 from both sides, so that we have negative x over 2 being less or equal than negative 11. Then multiply both sides by negative 2, and that will flip the inequality sign. So looking on negative 2 times negative x over 2 being greater or equal than negative 11 times negative 2. This simplifies to x being greater or equal than 22. Okay, so looking on the right portion, so again going to subtract 3 from both sides. We have negative x over 2 is greater or equal than 5. Now going to multiply both sides by negative 2 and flip the inequality sign. So we end up with x being less or equal than negative 10. So if we graph the two solutions, so for the first one we have x greater than 22. So we have everything to the right of 22. And for the second we have x less or equal than negative 10, so we're going to take everything to the left of negative 10. In interval notation, we're going to get interval from negative infinity up to negative 10 with a square bracket. Union with interval from 22 with square bracket up to positive infinity. So that's the deal with the first inequality. Now looking on the second inequality, we see again that it's not yet solved for the absolute value of 2x minus 11. So we're going to work on that. The thing that we can do right away is subtract 21 from both sides. That's pretty much the only thing we can do at this stage. So if we do that, we have negative 3 times absolute value of 2x minus 11 being greater than negative 10. Now we're going to divide both sides by negative 3. Since it is a negative number, we're going to reverse the inequality sign. So we end up with absolute value of 2x minus 11 being less than 10/3. And this is the inequality of the absolute value of some expression being less than a number type. So it is equivalent to compound inequality. So you have content of absolute value being less than that constant, or being greater or equal than negative constant. In our case, that boils down to 2x minus 11 being less than 10/3 and being greater than negative 10/3. So we're going to multiply all the way through by 3, and we're looking at negative 10 being less than 6x minus 33 and being less than 10. So after that we're going to add 33 all the way through. So we end up with 6x being less than 43 and being greater than 23. If we divide by 6, we're going to solve it for x. So we have x being less than 43/6 and being greater than 23/6. So if we get the graphical representation, it's going to be the interval between 23/6 and 43/6. And for the interval we get the open interval with parentheses next to 23/6 and 43/6. If we're going to solve this inequality that involves absolute value, so it's not yet quite ready for solving, since it's not yet solved for the absolute value of 3x plus 7. So to solve for the absolute value of 3x plus 7, we start by subtracting 6 from both sides. And when we're done subtracting 6 from both sides, we have 4 times absolute value of 3x plus 7 being greater or equal than 17. Now if we divide both sides by 4, we have absolute value of 3x plus 7 being greater or equal than 17 over 4. So this is inequality of the type absolute value of some expression being greater or equal than a constant. So it is going to be equivalent to two inequalities. Either the content of absolute value is less or equal than negative constant, or the content of absolute value is being greater or equal than the constant. So in our case, this is 3x plus 7 being less or equal than negative 17 quarters, or 3x plus 7 being greater or equal than 17 quarters. And we're going to solve each of those inequalities independently. So we start working on this left inequality. We multiply through by 4. We end up with 12x plus 28 being less or equal than negative 17. Then we're going to subtract 28 from both sides, so we end up with 12x less or equal than 45. Divided by 12, and we have x is less or equal than negative 45/12, which reduces to x being less or equal than negative 9 quarters. With the right inequality, we also multiply through by 4 to get rid of denominator. So we end up with 12x plus 28 being greater or equal than 17. Then subtract 28 from both sides, and we end up with 12x being greater or equal than negative 11. Divided by 12, and we have x being greater or equal than negative 11 over 12. So for the graphical representation, the first inequality says that x is less or equal than negative 9 quarters. So this is negative 9 quarters, and I'm going to take everything to the left of that. Second inequality says that x is greater or equal than negative 11/12. So negative 11/12 is actually to the right of negative 9 quarters. And we take everything that is greater than negative 11/2. So for the answer, we're going to have two intervals. One interval from negative infinity up to negative 9 quarters, and the other interval from negative 11/2 up to positive infinity. And we join those two intervals by the union symbol.